Hello there everyone, welcome to my YouTube channel. My name is Captain Lobo and today we're going to talk about Metar. Metar stands for Meteorological Aerodrome Report. This report is issued every hourly or half-hour basis. This report is provided to you guys mostly in a coded format. Now these coded format contains information about wind direction, velocity and various weather phenomena. So over here we're going to have a few examples about the Metar. Now as you guys can see, most of the information provided on the screen is always in an alphanumeric way. In this video we're going to learn how to decode this information in a specific way so that you guys can learn how to use a Metar. Alright, so let's explore Metar in detail. Like we see a statement over here written. Now the first word in your statement signifies Metar. This report has been issued specifically for Metar. If this is some other report, they will specify it like a TAF or a RO4. But since this report has been issued for Metar, the first word signifies that. Then the second word signifies which airport it has been issued for. So this VOBL is an ICAO code that stands for Bangalore. Then the next coded information we have, that is 170600Z. The first two digits signify the date. Then the next four digits signify the time in hours and minutes format, and the Z signifies that this has been in an UTC format. So it is issued on 17th at 0600 UTC, or you can pronounce it as Zulu. Then the next coded information that we have over here, that is 34004 KT. The first three digits of this signifies your wind direction. The next two digits over here signifies your wind speed. Now the wind direction which is provided over here is 340. That is always based on your true north. Now we have different perspectives. We have a true north and we have a magnetic north. All your Metar reports, wind speed and direction. Your wind direction is always provided based on your true north, that is your geographical north. So it is 340 degrees, 04 knots. Alright, so now let's try to read this entire thing. This report is a Metar report issued for Bangalore Airport, issued on 17th at 0600 UTC. Winds 340 degrees true, 04 knots. Okay. Now the winds that we've just seen, 340, 04 knots. Now anytime we never really have winds as 342 degrees, 343 degrees or 344 degrees. It will always be rounded up or down to the nearest 10 degrees. So if it is 340, next will be 350 or it will be 330. This 04 knots is an average speed taken over a period of 10 minutes. Now we'll see how winds can be written in different formats. So here are a few formats. That is 340 degrees, 04 meters per second, or it can also be said as 340 degrees, 04 kilometers per hour. So the symbol over here KT denotes it is for knots, MPS meters per second, KMH is kilometer per hour. Then anytime if you are experiencing gusts, if there are gusts around your airport and if that gust tends to exceed your mean speed by more than 10 knots, like the one which we have over here, that is 04 knots. If your gusting is more than 10 knots, that is beyond 14 knots, it will always be mentioned in your Metar as G. So 340 degrees, 04 knots, gusting to 25 knots. Okay, now we have a special condition, that is P. P, whenever you have P in your winds, that signifies that your wind speed is at 100 or beyond 100 knots. So like we have over here 340 degrees, 50 knots, gusting till 99 knots or beyond. Or if there are no gusts and if it is just your normal speed which is exceeding more than 100 knots, it will be denoted as this 340 degrees true, winds 99 knots or more. Now we have a special condition, that is anytime if your winds are varying in direction by more than 60 degrees. Now this phenomena does not really exist every now and then. This is a very rare situation. This may or may not be there depending if your wind direction is changing. Now the wind direction changing, it should not be like 5 degrees, 10 degrees. It should always be beyond 60 degrees. If any time you are experiencing a change in wind direction by more than 60 degrees, it will always be denoted as this 220 V300. That means your winds are varying from 220 till 300 degrees. Even these are your true north based wind directions. Anytime if the wind speed is less than 1 knot, it is always denoted or said as calm winds. It will be denoted as 340 00 knots. So that basically stands for calm winds. So let's have a look at how visibility is presented to us in your Metar. Your visibility is always presented to us in a meter format. So like the one that we see over here is 0650. That is the prevailing visibility in the aerodrome, that is 650 meters. Now let's have a look, like if let's say if one part of the aerodrome which does not really have the prevailing visibility, that is less than half of the prevailing visibility, or if it is below 1500 meters, it is always specified in a Metar as like this. The prevailing visibility in a Metar is 2000 meter, but in southwest it is 700 meters. Now let's look how different intervals affect your Metar. Now if the visibility is from 0 up till 800 meters, it is always given at intervals of 50 meters. For example, the one that we have over here, 0650 meters. Next it would be denoted as 0700 meters, then 750 meters and 800 meters. But anytime if it is beyond 800 meters up to 5000 meter, it is given at an interval of 100 meters. That would be like 800 meters, 900 meters, 1000, 1100 and so on. Now if visibility is beyond 5000 meters up to 9000 meters, it is given at an interval of 1 kilometer, that is 1000 meters. So it would be like, for example, 5000 meter, 6000 meter, 7000 meter, 8000 meter. Now beyond 9000 meter we have 10 kilometers. Now if any time our visibility is beyond 10 kilometers or 10 kilometers, it is always denoted in this format, 9999. So in Metar, if you see these words like numbers as 9999, it signifies the visibility is at 10 kilometers or beyond 10 kilometers. Now we have another special situation like 0000. Anytime we have a situation where in Metar we end up seeing 0000, this signifies that the visibility in Metar is below 50 meters. Okay, so next part of the Metar we have runway visual range, that is RVR. Your RVR is always provided whenever the horizontal visibility drops below 1500 meters. It is always denoted in a Metar by the letter R. So here we have RVR. The next part of the message is runway in use. So RVR for runway 27 right, or it would be left. If there is no left and right runway, it would directly be runway 27. So RVR for runway 27 right is 1100 meters. So here we have a few intervals like how RVR is presented to us. Like if any time your runway visual range is from 0 meters all the way up to 400 meters, it is always presented at an interval of 25 meters, like 25, 50, 75 and so on. Then from 400 meters all the way up to 800 meters in a Metar, it is presented at an interval of 50 meters, like 400 meters, 450, 500, 550 and so on. Then from 800 meters all the way up to 2000 meters, it is denoted at an interval of 100 meters, like 800, 900, 1000, 1100, so on. Now anytime if your RVR is beyond 1500 meters, it is always denoted with the letter P. So RVR for runway 27 right, 1500 meters or beyond. This signifies your RVR is either at 1500 meters or it is beyond 1500 meters. Now here we have a few trends in our Metar based on RVR. Now U, D and N, these signify increase, decrease and no change. Now anytime if we have like this RVR for runway 27 right, 0600 meters, that is 600 meters, U signifies increase. This signifies in the last 10 minutes RVR has increased by 100 meters or more. D signifies it has reduced by 100 meters or more. N signifies there has been no significant noticeable change in the RVR since the past 10 minutes. Okay, the next weather group in our Metar we have is the weather phenomena, as in the one that we see over here, which says plus SHRA, which stands for heavy showers and rain. Now these can be decoded by looking at this table below. Now in this table, the first section of the table signifies intensity or proximity, like how strong the weather phenomena is. If it is written as plus, the one that we see over here, plus SHRA, plus signifies heavy. If it would have been as minus sign, it signifies that it's just a light weather. If it is VC, it signifies in the vicinity of the airport, aerodrome, not exactly at that point, it's just in the vicinity. Moderate, if there is no plus or no negative sign, it is always a moderate weather. Now descriptor is just something that adds detail to the weather, like is it shallow weather, patches, blowing. Then we have weather phenomena. These are your main weather phenomena, which signifies what kind of a weather you are experiencing. Like precipitation signifies drizzle, rain, snow, ice crystals, pellets, hail. GS stands for small hail. PY stands for spray. Obscuration is like anything which is blocking your visibility. Like if we have mist, fog, smoke, like FU stands for smoke. DU stands for widespread dust. Any weather phenomena which is not really a part of precipitation and obscuration is always added in the other. That is your squall, then dust and swirls. Okay. Now these weather phenomena, like we also have thunderstorms. Now thunderstorm is always mentioned in a metar whenever it is heard in the last 10 minutes. It is always denoted as TS. It can also be like TSRA, like if you are hearing thunderstorms as well as you are experiencing rain. If there is no rain, it will only be denoted as TS, that is just purely thunderstorm. If in thunderstorm we are experiencing small hail that is less than 5 mm, it would be denoted as TSGS, that stands for thunderstorms and small hail. If we are experiencing in thunderstorm that is hail of more than 5 mm diameter, it would be as GR, TSGR. So looking at this table, we can literally decipher most of the weather phenomena and codes that is used in a metar on a daily basis. Now let's have a look at how fog is presented to us in metar. Fog can be presented in multiple ways depending on what kind of a fog it is. So let's have a look at different variations. The normal FG fog is presented whenever the visibility drops below 1000 meters. VCFG is presented whenever VCFG stands for fog in the vicinity. This is presented when the fog is outside the aerodrome but within 8 kilometers of the aerodrome boundary. Then BCFG stands for fog patches, like one single patch of fog has approached the aerodrome boundary. PRFG stands for a bank of fog, that a bank of fog has approached your aerodrome boundary or it has entered the aerodrome boundary. MIFG stands for mini fog or a shallow fog. This fog should not be more than 2 mm depth above the ground, and above this fog, like the above MIFG fog, you have a visibility of beyond 1000 meters. Now FZFG fog, this fog stands for freezing fog. This gives us a visibility less than 1000 meter and even your temperature drops below 0 degrees Celsius. Now let's have a look at how clouds are presented to us in a metar. Now clouds are always presented to us in terms of few, scattered, broken, overcast, like SCT stands for scattered. Now the best way to imagine this is think of a pizza. Now if a pizza has 8 slices, now if you have entire pizza to yourself, you can term it as an overcast. That means that your entire sky is covered up with clouds. Now out of pizza, if you, let's say out of 8 slices, if you just have 1 to 2 slices, we term it as few. Same thing with our sky. If your entire sky, if you just have 1 to 2 pieces of the sky which is covered with clouds, you call it as few. Then same concept applies to scattered, then broken, then overcast. Now let's have a look at few examples how it is presented to us in a metar. Like over here, you have scattered at 009. Now this 9, your clouds are always given to you in hundreds of feet. Like you're scattered at 009, that is scattered at 900 feet, broken at 1900 feet, overcast at 2000 feet. Now all of these heights, 900, 1900 and 2000, they are all in terms of QFE, that is height above ground level. It is not QNH. It is always presented to you as QFE, that is height above your ground level. Then we have a special condition where you have CB and TCU presented to us. These are the only types of clouds that is presented to you in a cloud format. That is, only convective clouds are presented in a cloud base. That is, overcast at 2000 feet, cumulonimbus, broken at 1500 feet, towering cumulonimbus. We don't really have any other clouds like Altus, Stratus, Cirrus. Only convective clouds are presented to us. Only they are named to us in this format. Now anytime if the entire sky does not have even a single cloud, it is always denoted as SKC, which stands for sky clear. Now let's have a look at the entire metar. In this metar, if you see, we have a visibility of 3000 meter, few clouds at 900 feet, broken at 1500 feet. Now let's say if in your entire metar, if you have multiple cloud bases, it is always presented in an ascending format, like 900 feet, then next comes is 1500 feet, like that, and so on. Now let's have a look at a few special conditions, like the one that we see over here, VV002. If the sky at an aerodrome is obscured for any other reasons other than cloud cover, it is always denoted to you as VV, which stands for vertical visibility. So let's have a look at this. This would mean 100-meter visibility, fog, vertical visibility is 200 feet. Again, it is always in a 100 feet format. Now, the one that we see over here, VV /3 times, this is presented to us anytime whenever we cannot determine as to how much the vertical visibility is, like the one which we had over here, that was 200 feet. Over here, we really have no idea as to how much the vertical visibility is. So it will always be denoted as VV and /thrice. Let's look at another word in a Metar, which is Capt, which stands for cloud and visibility are okay. Whenever Capt is included in Metar, it replaces the words as RVR, visibility, weather phenomena, and cloud base. To have a Capt in Metar, you have to fulfill these weather conditions, that is, your visibility must be 10 kilometers or beyond. The height of the lowest cloud must not be less than 5,000 feet, or level of highest minimum sector altitude, whichever is the greatest. There must be no cumulonimbus present, and there must be no significant weather. Now let's look at an example of Capt. Like again, Metar for Bangalore issued on 17th at 0600 UTC. Winds 340 degrees true, 04 knots. Cloud and visibility are okay. Now looking at this example, you'll notice that there is no weather phenomena, nor there is a cloud ceiling, nor there is an RVR issued, because this word literally replaces all of those words. Now let's look at another weather phenomena in a Metar. Over here, after Capt, the one that we see 10/02, the first two denote your outside air temperature, the next two denote your dew point temperature. That is, outside air temperature 10 degrees Celsius, dew point 02 degrees Celsius. Then the one that we seeing over here is 10/M02. Now temperatures, if anytime the temperature is in negative, like -1, -2, -3, like in weather situation, it is not really given as a negative sign, it is always written as M. M signifies minus. So this stands for 10 degrees outside air temperature. Dew point is -02 degrees Celsius. Now let's look at how temperatures are rounded off. 2.5 degrees Celsius is 03 degrees Celsius. All your temperatures are rounded off to the highest value, that is 34 degrees Celsius will be rounded off to 03. Negative 2.5 degrees Celsius will be written as M02. Next, we have a pressure group provided to us in a Metar, that is a QNH. Now QNH is the only pressure group that is available to us in a Metar. Like for example, we have here QNH 0991, always in a 4-digit format. If ever it is less than 1000, it always starts with 0. Now QNH is presented in a multiple formats, like in inches of mercury or in a hectopascal manner. Now as we saw for temperature, it was always rounded off to the highest value, but for QNH, for safety reasons, it is always rounded down to the lowest value. Like the one that we see over here, that is QNH 991.6 HPa, will be written in a Metar as 0.991 hectopascal. But if anytime, if Q codes, if the QNH in a Metar is given in inches of mercury, it is always given in a practical decimal format, that is QNH 29.902 inches of mercury. Only hectopascal gets rounded off, but whereas inches of mercury, we take it as it is in a proper decimal format. Now let's have a look at another coded information which is presented in Metar, which starts with the letter RE. Like the one that we just see over here, RETS. RE stands for recent weather. Anytime in the past hour, or since the Metar was, or since the last Metar which was issued, if there has been a significant change in the weather, like if it has ceased off, or if the weather has reduced, it is always mentioned in the Metar, like the one over here. It says recent thunderstorm. That means in the last hour there was a thunderstorm activity. Now let's see how wind shear is depicted in our Metar. Over here it says wind shear all runway. Now let's say if an airport has multiple runways and every single runway is experiencing wind shear, it will be written as WS stands for wind shear for all runways. Now if there are multiple runways, or if there's a specific runway which is experiencing wind shear, it will be denoted in a specific format, like wind shear For runway 27 right. So we have another section of a metar which stands for trend. Trend is valid for 2 hours after the time of observation of the metar. This mostly constitutes the final section of a metar. Trend is further classified in another 2-3 different parts that can be written as becoming, temporary, no sig, BECMG, that is becoming. Becoming is mostly a gradual change, that is a permanent change. It can be written in a meta that is becoming from so and so time. That time will always be a UTC time and up to what time it is. Then tempo. Tempo stands for temporary change. This temporary change is like a change which we are expecting for it to be less than an hour. So again, like if we see over here, temporary change from 1020 till 1220 UTC, winds 240 degrees true, 25 knots, gusting till 45 knots. Then whenever we have no sig written in our metar, it stands for no significant change in the next 2 hours. Like whenever we have this, we're not really going to expect any further change in the metar for another 2 hours. Then we have a final coded message in a metar, that is an equal to sign. Whenever we have equal to sign in a metar, this signifies the end of the message. Like this is like a closing point of a metar. Alright, thank you all for watching this video. I hope you guys by now have found this video very enjoyable and informative. And by now I hope you guys have pretty much grasped as to what is metar and how to decode it. So just to test your knowledge, I'm gonna put a metar on the screen so you guys can try to decode it and post it in the comment section. And if anyone has any doubts or queries, you guys can get in touch with me on the provided details. I'll provide it in the description section. And make sure to hit the like and subscribe this channel. Thank you all everyone. Have a good day. Take care.